Hi everyone, and welcome to this new video of Math Puzzle with Q. In today's video we are going to talk about the Christmas Carol, the 12 Days of Christmas, and the math behind it. The 12 Days of Christmas Carol is a traditional Christmas carol in which, during each of the 12 days of Christmas, an increasing number of gifts are being offered. During the first day, only one gift is being offered. During the second day, 1 plus 2 gifts are being offered, etc. And during the 12th day of Christmas, the number of gifts that are being offered are 1 plus 2 plus etc. etc. plus 12. So the first question that someone may ask is, what is the total number of gifts at the end? Well, in this particular case where the number of days is equal to 12, you can find that the total number of gifts is equal to 364. But a more interesting question from the math perspective is, what is the total number of gifts when the number of days is equal to n? And what is the general formula for the total number of gifts? So let's first with the general formula. So if we add n days of offering gift, the total number of gifts will be equal to 1 plus 1 plus 2 plus 1 plus 2 plus 3 plus etc. etc. plus 1 plus 2 plus 3 etc. etc. up to the number n. So in this video we are going to find not just one way but actually up to 3 ways to find a general formula for this sum. So in the first way, what we're going to notice is that the sum from k equal 1 to n of the number k is actually a well-known sum, and this sum is equal to n multiplied by n plus 1 divided by 2. The thing we're going to do here is to distribute this n plus 1 divided by 2 into n squared and n. So this gives us 2 sums in the next step. And then we know that the sum of the n squared is equal to big N plus 1, 2 big N plus 1 divided by 6. And again, the sum of the small n is equal to big N multiplied by big N plus 1 divided by 2. Now we can put the big N plus 1 divided by 2 in factor. This can be simplified into big N plus 1, big N plus 2 divided by 6. This can be written as the product from 2 to big N plus 2 on the numerator, divided by 6 multiplied by the product from 2 to big N minus 1 on the denominator. And you may recognize that this is equal to big N plus 2 factorial divided by 3 factorial n plus 2 minus 3 factorial, which is equal to the number big N plus 2 choose 3. So that was the first way to identify a nice formula for this sum. But there is actually another way to find this formula. What we're going to do here is to group the element of the sum in a different way. So let's start by writing a table where we are going to show the value of small k and the value of small n. And what you can see from that table is that we can arrange the number in a triangular pattern. And what we were doing previously is we were summing the rows of that arrangement. So we were adding the 1, then the 1 and 2, then the 1 and 2 and 3, etc. But instead, nothing prevents us to summing the column instead of the row of the table. So what we can do here is to take all the 1 together, and we have 5 1, then sum the 4 2, then sum the 3 3, etc. So this is basically giving us another way to write this sum. The other way we can write this sum is 1 plus 1 plus 1, etc. plus 1, 2 plus 2 plus 2 plus 2, etc., 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 all the way to the number n that we calculate only one time. This formula can be rewritten as n multiplied by 1, n minus 1 multiplied by 2, plus etc., etc., plus 1 multiplied by n. In other words, this is equal to the sum from small n equal 1 to big N of big N plus 1 minus small n multiplied by small n. This can be expanded as the sum from small n equal 1 to big N of small n minus the sum from small n equal 1 to big N of small n square. And here again, we can simplify. So we have big N plus 1 multiplied by big N plus 1 divided by 2 on one hand. And on the other hand, big N plus 1, 2 big N plus 1 divided by 6. We can simplify this again by putting the big N plus 1 divided by 6 in factor, which simplify as big N plus 1, big N plus 2 divided by 6, which is again equal to big N plus 2, choose 3. Okay, that was a nice other way to find this formula, but is there another, maybe more visual way to describe this sum? Well, actually there is. So in this new way, what we're going to do is that we're going to represent each individual gift by a little cube into a three-dimensional space. So let's say here that the number of day big N is equal to 5. So we'd start with 1 plus 2 plus 3 plus 4 plus 5. Then 1 plus 2 plus 3 plus 4. Then 1 plus 2 plus 3. 1 plus 2. And then the final gift 1. Now what you can see here is that all this little cube fits nicely inside a sort of pyramid, which can be itself embedded within a cube. Let's turn around this cube to see it from a different angle. And what you can notice here is that if you were to calculate the volume of this yellow pyramid, you would have a volume that is exactly equal to 1/6 of the volume of the cube. So at the end, it is not that surprising that the final formula for the total number of small cube is equal to n plus 1, n plus 2 divided by 6, because we have the same number 6 as in the volume factor described here. And on top of that, the n plus 1, n plus 2 is very close to a n cube. But if we want to be a tiny bit more rigorous here, we can say that the total number of little cube here is equal to the total number of xyz integer between 1 and n, such that the sum of x plus y plus z is lower or equal than n plus 2. And I'm not going to give more explanation about this here, you can try to find it yourself and tell me in the comment below. But basically you can verify that this equation is the equation that represents the number of small cube in this pyramid. An alternative way to represent this set is to represent it by the set of xyz integer between 1 and n plus 2, such that x is strictly lower than y, which is strictly lower than z. Here again, you can let me know in the comment below how you find this equation. But at the end, this formula exactly represents the number of ways to choose 3 elements among n plus 2 elements, which is exactly equal to n plus 2 choose 3. So here we go. With this other way of visualizing the formula, we find exactly the same formula as before. N plus 2, choose 3. That's it for this video today, I hope you liked it, and if by any chance you know of any other way to demonstrate this formula, please let us know in the comments below.